Hello students, this is your economics coach Prateek Bhasin back with chapter 7 of statistics, that is correlation. In today's class we will be studying about Carl Pearson's method. We have already discussed what is correlation and how do we measure it. We have already studied scatter diagrams. We also know what are the different types of correlationship. In today's class, as we will be discussing Carl Pearson's method, let us move on to the formulas and the merits and demerits of Carl Pearson's method. So, first of all, I will be discussing the merits and demerits of Carl Pearson's method. So, we have that the first merit for Carl Pearson's method is it is independent of both origin and scale and hence can be easily calculated. Similarly, the second merit says that it shows the direction as well as the exact degree of correlationship between the two variables. But there are some demerits as well. The first demerit is it is affected by extreme values because we are calculating mean or we are taking assumed mean. This means it is affected by extreme values. The second demerit is it assumes linear relationship. Now, what does linear relationship means? Linear relationship means that the correlation between two variables can be drawn as a simple line on a graph paper, but it may not always be true. So, this is a demerit of Carl Pearson's method. I will discuss these again after doing the questions of this chapter. So, we have the first question in place. I have taken easy values for you so that you can easily understand it. So, we have two variables x and y. The values of x is 10, 20 and 30 and the values of y is 7, 14 and 21. Now, under Carl Pearson's method, we have four methods to calculate coefficient of correlationship. The first method is actual mean method. The formula for this is sigma xy upon n standard deviation of x multiplied by standard deviation of y. Basically, this part sigma xy upon n is covariance of x and y. This can also be rewritten as sigma xy upon square root of sigma x square into sigma y square. Now, what is this x and y? This small x actually represents the difference between the variable x and the mean. Similarly, small y depicts the difference between the variable y and the mean. So, first of all, we will be doing the question using actual mean method. So, now let us move on to the question and calculate the mean. So, we have x 10, 20 and 30 and y as 7, 14 and 21. So, first of all, let us calculate the mean. So, let us total the values of x which will be 60. So, to calculate mean we have the formula sigma x by n. So, which will be 60 by 3, this means my mean is 20. Now, let us find the value of small x which is represented by capital X minus mean. So, this will be minus 10, 0 and 10. Now, let us square these values. So, we get x square which will be 100, 0 and 100 again. Let us total them, we will get 200. Now, let us do the same thing for the variable y. So, the total for variable y is 42. So, y bar, this means mean for y series will be sigma y by n which will be 42 by 3, that is 14. Now, let us calculate small y which will be capital Y minus mean of y minus 7, 0 and 7. Let us square these values. So, we get y square which will be 49, 0 and 49. The total to this will be 98. In the formula, we have sigma xy upon root of sigma x square into sigma y square. So, we also have to calculate the value of x and y. So, now let us calculate the value of x multiplied by y. So, small x into small y. So, we have these two, this is small x and this is small y, we have to multiply these values. So, first value is 70, the next is 0 multiplied by 0 which is 0 and then it is 70 again. This will be 140. Now, let us put these values into the formula. So, we have to calculate the correlation coefficient. So, the formula to this will be, according to our actual mean method, is sigma small x into y upon square root of sigma x square into sigma y square. So, the values will be 140 upon root 200 upon root 98. This will give me a value of 140 upon root of 19,600, and the root for 19,600 is 140 again. So, the answer to this question will be 1, which represents perfect positive correlationship between x and y. This means they move in the same direction with the same degree. Now, let us move on to our second method, which is the direct method. So, let us first see the formula to this. So, we have sigma xy minus n mean of x multiplied by mean of y upon square root of sigma x square minus n mean of x the whole square multiplied with the square root of sigma y square minus n the mean of y square. So, let us do this question using this formula. So, we have x, we also have y. We have x as 10, 20 and 30. We have y as 7, 14 and 21. We already have the means of these series, which is 20 and 14. So, I have x bar as 20 and y bar as 14. Now, what all do I have to calculate? I need to calculate x multiplied by y. I also need to calculate x square and I also need to calculate y square. So, let me calculate x square first. So, I have x square as 100, 400 and 900. The total to this will be 1400. Similarly, I also have to calculate y square. It will be 49, 196 and 441. So, the total to this will be 686. Now, I also have to calculate the multiplication of x and y. So, this will be 10 into 7, which will be 70, 20 into 14, which will be 280, then 30 into 21, which will be 630. The total to this will be 980. Now, let us put these values into the formula. So, the correlation coefficient can be obtained by the formula sigma capital X into y minus n mean of x into mean of y upon square root of sigma x square minus n mean of x the whole square multiplied with sigma y square minus n the mean of y square. Now, let us put the values. So, the values are 980 minus 3, this is the number of variables in the series, x bar is 20, y bar is 14 upon sigma x square, the value to sigma x square is 1400. So, 1400 minus 3 into 20 square, because the mean of x series is 20. Similarly, square root of sigma y square. So, sigma y square was 686 minus 3 into 14 the whole square. So, let us calculate the values. So, we have 980 minus 20 into 360 into 14, which will be 840. So, in the numerator we get 140 and in the denominator we have 1400 minus 1200 and 686 minus 588. So, this will be 200 into square root of 98. So, we have the same calculation again, which will be 140 upon square root of 19,600. This will give me an answer again of 140 upon 140, which will be 1. So, this is perfect positive correlationship. Now, let us move on to our third method, which is the assumed mean method. Under this method, we take an assumed mean and not the actual mean to calculate the coefficient of correlationship. Now, let us first write the series which is 10, 20 and 30. Y is 7, 14 and 21. So, let me assume the means. Let me assume 10 to be the mean for the x series and 21 to be the assumed mean for y series. Now, let us first look at the formula. So, we have this formula which is n sigma dx into dy minus sigma dx into sigma dy upon square root of n sigma dx square minus sigma dx the whole square multiplied with the square root of n sigma dy square minus sigma dy the whole square. So, this is our formula. So, let us first calculate the value of dx and dy. So, basically dx is the difference between x and the assumed mean. So, I am assuming assumed mean to be a. So, let us find these values which will be 0, 10, positive 10 and positive 20. Now, I also need the value of dx square because it is to be used here. So, let us find the value of dx square which will be 0, 100 and 400. This will give me a value of 500. I also need to calculate the value of dy. So, dy is y minus assumed mean of y series which will be minus 14, minus 7 and 0. Now, let us square these values. So, this will be dy square which will be 196, 49 and 0. The total to this will be 245. Now, I need to calculate dx multiplied by dy. So, I need to calculate dx dy. So, we have dx as 0, dy as minus 14. So, the value will be 0. Then we have 10 into minus 7 which will be minus 70. Then we have 20 into 0 which will be 0 again. So, the value of dx dy will be minus 70. Okay. So, we need dx dy, we have it. We also need to calculate sigma dx and sigma dy. So, let us first calculate the totals of dx and dy. So, this will be 30 and this will be minus 21. Now, let us put these values into the formula. So, we have n sigma dx dy minus sigma dx into sigma dy upon square root of n sigma dx square minus sigma dx the whole square multiplied with the square root of n sigma dy square minus sigma dy the whole square. So, let us put the values. So, we have n as 3, sigma dx dy which was minus 70. So, let me put the value as minus 70. Then we have sigma dx into sigma dy. So, 30 into minus 21, 30 into minus 21. Now, we have n. So, the value of sigma dx square is 500 minus sigma dx the whole square which is 30's square. Then I have 3 into 245 minus sigma dy which is 21 raised to the power of 2. So, let me calculate this for you. So, this will be minus 210 plus 630 upon 1500 minus 900 root of 735 minus 441. So, this will be 420 upon root of 600 upon root of 294. Now, this will be 420 upon square root of 1,76,000 which will be again 420. So, my answer will be 1, that is perfect positive correlationship. Now, let us do the same question using step deviation method. So, let me write the question for you first. So, we have x, 10, 20 and 30. y 7, 14 and 21. I am assuming 10 to be the assumed mean and 21 to be the assumed mean for y series. So, let us first calculate dx. So, dx will be 0, 10 and 20. Now, we see that we can pull out a common denominator of 10 from this series. So, we can actually calculate dx dash, which will actually be dx by common factor. So, we have 0, 1 and 2. Let us total this, this will be 3. Let us square this. So, we have dx dash the whole square. So, this will be 0, 1 and 4. The total will be 5. Moving ahead, we have y. So, we need to calculate dy, which will be minus 14, minus 7 and 0. Now, let us pull out a common factor 7 from this series. So, we have dy by c, which is 7. So, minus 2, minus 1 and 0. So, the total is minus 3. Now, we have dy dash the whole square, which will be 4, 1 and 0. So, the total to this will be 5. We also have to calculate dx dash and dy dash. So, we have dx dash into dy dash, which will be 0, 1 into minus 1, which will be minus 1, 2 into 0, which will be 0. So, we have minus 1 here. Now, let us write the formula for this. So, the formula to this will be n sigma dx dash dy dash minus sigma dx dash into sigma dy dash upon n sigma dx dash the whole square minus sigma dx dash the whole square into square root of n sigma dy dash square minus sigma d dash y the whole square. So, let us put in the values. So, the number of series is 3, then we have sigma dx dash into dy dash, which is minus 1, then we have sigma dx dash, which is 3, sigma dy dash, which is minus 3, then we have n, which is 3, sigma d dash x square, which is 5, minus sigma d dash x the whole square, which is 3 square. Then again we have number of series is 3, sigma d dash y the whole square, which is 5, minus 3 the whole square. So, let us calculate. This will be minus 3 plus 9, then we have 15 minus 9, and then we have again 15 minus 9. So, this will be 6 upon or root 6 into root 6. So, the answer to this question will again be 1. So, this will be perfect positive correlationship. So, this was my first question. Let us move on to our next question, which I will be solving using the assumed mean method. So, we have this question in place where we have capital employed and profit. So, assuming capital employed to be x and profit to be y. So, we have 2, 3, 5, 6, 8 and 9, and then we have 6, 5, 7, 8, 12 and 11. So, I am assuming 5 to be the mean in the x series and 8 to be mean in the y series. So, let me calculate dx first. So, dx will actually be the difference between x and the assumed mean. So, this will be minus 3, minus 2, 0, 1, 3 and 4. So, the total to this will be 3. Now, I have dy. dy is actually y minus a. So, I have assumed 8 to be the mean. So, this will be minus 2, minus 3, minus 1, 0, 4 and 3. The total to this will be 1. So, we have dx square, which will be 9, 4, 0, 1, 9 and 12. So, the total to dx square will be 39. Now, let us calculate dy square. So, this will be 4, 9, 1, 0, 16 and 9 again. So, the total to dy square will again be 39. Now, let us calculate dx multiplied by dy. So, minus 3 into minus 2 which will be 6, minus 2 into minus 3 which will again be 6, 0 into minus 1 will be 0, 1 into 0 will be 0, 3 into 4 will be 12, 4 into 3 will also be 12. So, the total to this will be 36. Let us put these values into the formula. So, we have the correlation coefficient to be calculated as n sigma dx dy minus sigma dx upon multiplied with sigma dy upon square root of n sigma dx square minus sigma dx the whole square multiplied with the square root of n sigma dy square minus sigma dy the whole square. So, let us put in the values. So, the number of items in these series is 6. The total to dx into dy is 36 minus 3 into 1, because the total to sigma dx was 3 and total to sigma dy was 1, upon number of items is 6 into sigma dx square is 39 minus sigma dx the whole square. So, 3 square. Similarly, 6 into 39 minus sigma dy was 1. So, 1 square. So, this will be 216 minus 3 upon 39 6 is 234 minus 9, and this will again be 234 minus 1. So, we have 213 upon root 225 into root 233. So, this will give me a value of 213, 15 and root of 233 which will be 15.26. So, my final answer to this question will be 0.93 and a positive sign. So, this will give me high degree of positive correlationship, because the answer is greater than positive 0.9. So, it will be very high degree of positive correlationship. So, this was how we do the Karl Pearson's method. So, let me discuss the merits and demerits of this method again. So, we had that it is independent of both series and scale and hence can be easily calculated. So, if I had a series which is 10, 20 and 30, 7, 14 and 21, I could actually reduce the size of this series by dividing it with a common denominator. This would also give me the answer whether I had removed the scale or not. Similarly, I can also change the origin, means that if I add a specific number to the series, I will still get the same answer. Then we have, it shows the direction, that means the positive or negative sign, as well as the exact degree, that is the coefficient. But it is affected by extreme values because we have to calculate mean. So, there is a role of the mean there and it assumes to be a linear relationship, which may not be true in all the series. So, I hope you were able to cope up with this lecture. I request you to calculate some questions from your notebook or from your book and do them simultaneously. So, I will see you in the next class. Till then, bye and take care.